All right, I don't know why it keeps ending my stream, but we finished the algorithm. So we have LLT. We finished while I was waiting for the third stream to start. Cool. So, yeah. Where is the homework? Where'd the homework go? Wait, what? What the hell? All right, anyway, so we have LLT, so now we just need the D, which is going to go ahead and be, so LD is going to go ahead and be this. 1, 1, 1, 1. How did it work? We divided the whole row by 1. So that's just going to be 1. That's just going to be, whoops, that's going to be 1 still, that's going to be 2. Divide this whole row, that's still going to be the same. Divide this whole row, that's going to be like that. Divide this whole row, it's just like that. So then we have 1, 1, 2, 4. So that means we'll also have to take it out from that side. So LT. Just got to multiply by itself again, right? Yeah. We just got to square it. So that's going to be 4. That's going to be 16. And then we just throw this guy up here. 1, 1, 1, 1. 0, 1, -2. Oh, what? Yo. Stop. Stop it. All right, hold on. We throw the transpose up here. Rows turn to columns. Rows turn to columns. Rows turn to columns. Rows turn to columns. Right. Rows turn to columns. Yeah. All right. So we got our LDLT. Boop. Take that, Dr. Prasad. All right. Now we also need to do find the square root of the matrix above. Basically, what we have to do is diagonalize it. And diagonalizing it allows us to look at the eigenvalues. And then we just do 1/2 on them hoes. Thing is it QD/QT? Is that diagonalization? Shoot, I forget. Please don't be anything sus over here. Math. Just go to table of contents. Diagonalization 115. Almost there. Not you. We want this. Oh, it's PDP squared. Oh, P is the eigenvectors. All right, my bad. So it's saying we could just use a script to find the eigen decomposition. So we're just going to ask ChatGPT. Because it's a 4x4. That shit would take me like an hour on hand. All right, so man, but ChatGPT sucks sometimes, dude. At this stuff. All right, whatever. We're just gonna risk it. Can you give me the eigen decomposition of P D P negative 1 of the matrix for these 1 0 1 whoops 1 0 1 0 1 negative 2 0 1 0 negative 1 negative 1 1 0 5 0 and negative 2 negative 1 0 15. No need to show me the work, just show me the results. All right, so it says use that to find the decomposition. All right, so used script for decomposition. That's going to go ahead and be LDL, PDL negative, P equals, god dang, hurry, fuck, what the hell, what? Oh my gosh, all right, fine. Oh my god, what is this? What is this? What the hell is this? Zero 0.215, 0.9284, 0. Let me move this to the side so that I'm not distracted by time. What I like to do when I'm studying is hide all my clocks so that the concept of time is just lost. Because when I used to do Pomodoro, I would always be like predicting and waiting for that timer to go off so I can go chill out and fuck off. But if I don't know what time it is, I only take breaks when I feel like it, and usually that's like after an hour or so, and I don't have to like be anxious about waiting for the time. Damn, Dr. Prasad, what the heck? It's a crazy example you gave us here. Baby, tonight, I think I was falling in love again. Baby, tonight, the DJ was falling in love, you know. So dance, 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 dun, 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 dun. So baby, tonight, the DJ dun, 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 again. Yeah, so dance. Dun, 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 dun. It's kind of weird that we got the transpose. But is P a orthogonal vector? It is, isn't it? No way. P is an orthogonal vector. So every time I found the eigen decomposition and I literally did the whole process to find the inverse, it's literally just the transpose. Because we know that for an orthogonal vector, the orthogonal matrix, the inverse is equal to the transpose. That's crazy. That is absolutely wicked, bro. Oh my gosh. Look at the magic in that. Frick me, right? So dance, 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 and maybe tonight, the baby was wandering on again. So dance, dance, dance till the night. Dun, 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 dun. Damn, bro. All right, so that means that the square root is just going to be equal to this. Boom. All right, next problem. Question 4, baby. Let's go. Consider the matrix A equals 3, negative 2, 2, negative 2, 3, 2. Find the singular value decomposition of A. Sure, why not? And a pseudo inverse. So I watched a video on the topic. I remember that the idea, it's not here, is it? Yeah. I remember that the idea is that any matrix, regardless of dimension, rank, whatever, any matrix can be decompositioned into a freaking what do you call it? Into it can be decomposed. There's a decomposition. All right. So let's check it out. Right. Any arbitrary matrix can be factored. Okay, factored. where U is orthogonal, rotation, M is diagonal, scale, and V is, oh yeah, I remember U is like, is like, it's like the, something about the left eigenvectors or something. Let me look at my notes really quick for singular value decomposition. Oh, so you can create a symmetric matrix with a rectangle and be like, you can have the left and the right. Left would be A, AT. The right would be AT and A. And you find the eigenvectors of those. And those would be the thingy. And D, I guess, would be, what would D be? D would be the singular values. What the hell are those? All right, let's check it out. Yep. Rotation, scaling, and rotation. Yep. What are these? For U, yeah, and R is yeah. U and not. They're not square matrices. What is this? It's kind of weird that we weren't tested on this. He's like basically saying you guys can't handle it. It's whack. It's pretty whack. I can handle it. I just gotta study a bit. Oh, I don't know what I'm doing. There's shit. There's nothing hard about this. You just have to hit it, really. The only thing I'm concerned about is what is this again? Let's peep the video again about yo, that's what I'm doing. SVD visualize. Being finance is pretty cool. Oh, really? And these eigenvalues are of either one. Okay. Okay, bet. That's light. All right, let's hit it. Oh my gosh, that's so light. All right, let's hit that. Find the singular value decomposition. I bet. So let's do the left. And the left is A times AT. Let's double check. Yeah. Yeah, bro. AT is going to be equal to All right, hold on. So we're going to do this times that. Wait, no. This times that. That's going to be 9 plus 4, 13. We're going to do... Oh, man. Fuck. We got to do the Wait. Wait, no, we're chilling, actually. Wait, we're chilling. Hold on. So that's 13. That is -6 minus -6, 0. That's going to be 6 minus -4, 10. -6 minus -6, 0. Oh, yeah, it's symmetric, so we already know these. This times, what am I doing? This times that is going to be 4 minus 9, -5. Okay. And then that times that is going to be -4 plus 6, 2. That's going to be 2 as well. Then we'll do this times that. That's going to be 4. No, 8. All right, because 2 times 2, 4, plus 2 times 2, 4 again. All right, so then ATA is going to be equal to go ahead and flip that. Stop. So that's going to be a 2 by 2. All right. That times that is going to be equal to 9 plus 4, 13, plus 4, 17. What a great number to work with. Let's double check. 9 plus 4 plus, wait. Yeah. and negative 24. So, cool. So our eigenvectors are 9 and 24. So now what we can do is something. Eigenvectors. Yes. Wait, bro. I just realized we need the eigenvectors for both of these. Man, come on, bro. Right? Because bro, you cannot do this to me. Gotta find the eigen decomposition of both of them. Come on, bro. I can't do all that. All right. So, all right. So, I'm gonna find two vectors real quick. So, I'm gonna double check what we got here. What is the eigen decomposition of just 2 by 2 real quick? 17, negative 8, and 17. No, negative 8 and 17. Wait, not decomposition. I wonder why ChatGPT takes so long. LinkedIn takes a long time for me as well. I don't know why on this computer. So weird. $25 and 9. 25? Oh yeah, 25. I'm done. So that means the vectors are going to be 0.7001 and negative 0.7071. 0.7071, 0.7071. Negative there. All right, so we're also going to do the decomposition here. Come on. Yeah. Mm-hmm. 13, 0, 10, 0, 5, negative 5, and 2, 10, 2, and 8. No need to show me the work. Just show the result. All right, so we're going to have Oh, so the eigenvalues are actually the same. Data analysis limit. Oh, shoot. It's not good. Oh, so it's that simple, really? All right, let's try that. Just a little test here. So the eigenvalue should be the same. What the fuck? What the hell? Bro. It's not good, guys. Three, -2. Did I copy it wrong, man? Dang. No, I did not. It's good. -3. I mean, yeah. Oh, what the hell? I did something wrong. That's weird. Okay. Nice. How did I do that wrong? This times that is -6 minus -6. That's 6. That's 6. That's -6 plus 6. What? Wait, bro, it's not minus. It is not gosh darn minus. Does that mean I fucked up here too? It is not minus, it's plus. 9 plus 4 plus 4, 17. -6 plus -6. Oh, -12 plus. Okay, so we still got that right. What the heck were we doing? You silly Billy Nelson. You silly Billy, you. All right, so let's do the correct one. -12, 2. That's still 2. 13 here. That's also going to be 2. That is -12. Yeah. So we get. Okay, fuck off. I hate you. I hate you. I hate you. What is this? Wait. What? Wait. Is it just fucking 25? All right. So you had to get all specific on me. All right. I don't know why you had to do that. You scared me, but Looks like it's gonna be. Come on, dude. Why do you have to get all specific on me? What is this? Bro. Trying again tomorrow after 8:02. Come on, bro. Trying it tomorrow after 8:02. Sure. Guess we can come back at 8:02. All right, whatever. If I just do this. Damn. How do I make it so it doesn't give me like exact answers? Oh my gosh. All right. Nope. So next question. What is pseudo inverse? What the hell? I don't know. Such a mission, dude. This is so annoying. Jason Ball's birthday 06/20/2005. Let's go. Yo. Oh shit. Wait. Fuck. -13, -12, 2, -12, 13, 2, 228. Negative 0.707, 0.707, 0, 0.667, 0.667, negative 0.333, 0.236, 0.236, 0.94. This is 2509, so 0.943. So let's do 9 and 25 instead. So we're going to do the decomposition is going to be C A equals U which equals we're going to say so we're gonna do 25 and 9. Let's switch that. Oh no, let's do 9 and 25. And then the 0 can go over there, and the 9 can go over here. 9, 25. This can be like that. All right, boom. We gotta take a pee. I'll be right back.
Yeah, I'm kind of cold, guys. Ah, shoot. Wish I had a sweater. Might as well go get one. Where's my phone at? Yeah, I'm gonna get a sweater, man. It's too cold up here. You just turn up the temperature, I guess. I don't know. I'm gonna just do my kind of stuff. Ready. So, yeah, what is a pseudo-inverse matrix? Pseudo-inverse. What the fuck? Okay. Still a bit confused. Given by diagonal.
What is the diagonal? What are these? I'm guessing the eigenvectors. Oh, wait. Oh, it's just of rank R is the pseudo inverse of a rectangular matrix this goes to also the rank. So you're telling me the rank of this matrix is 2. Probably. Let's take a peek at this rank. Here we got here 3 by 2. The hell do you mean? Go down. Frick off. I guess we can divide that by 3, get 1, negative 2, negative 2, 2, 3, 2, 3, 2, 2. Or, I mean, we might as well throw this up here. We get 1, 1, 3, negative 2, negative 2, 3. Can't we? I really feel like we can just eliminate this. And that's why it's rank 2. Okay. So, sure. Boom. That was pretty easy. I'll have to get more into the nitty gritty of what this really is doing when we have a bit more free time. So let's use the SVD to find the SVD. Is it? You know, my stumpness at such a problem really just shows how little I understand about the application of this. Because the reason that's probably a problem is because we can easily calculate that with what we have here. Let's ask ChatGPT what the hell this means. Throw this over a little bit. Yeah. So, how can I use the SVD of A to find the SVD of the matrix A T times A negative 2 times A T. I do remember him going over things like that. I think it's here. Okay. Yeah, I remember doing some of these. Okay. All right, so I guess we can do that. Let's see. So I guess what we can do is ATA. Okay, well, let's think about it. So find ATA negative 2 AT. That can be like this. Transpose of that. It's going to be UT. I'm pretty sure it's like this, actually. Cancels out. That does not cancel out. Does it? Yeah, so only that cancels out. Wait. Shouldn't this cancel out? Shouldn't that? The U is orthogonal. E is a diagonal, so it would be times. So that wouldn't just turn into the identity. So we can't really just get rid of it. All right. I see. Okay. And then I guess if we do it to the second power, it would be would that be given to everyone? Multiplied, so it'd be negative 4 V T negative 2 negative 2T. Let me get my properties out. Transpose properties. Sure. Yeah. But for some reason it's not applied on V. Why not? Hmm. Hmm. Oh, you. Huh. So we know it's diagonalizable. It's a diagonalization. Strange. Since it's diagonal. So diagonal, orthogonal. What is an orthogonal matrix? A diagonal is not orthogonal. Yeah, no way. So, what the fuck? So we can't do anything about this. We can't simplify it further. Is that what we get here? Yo, is ChatGPT making me dumb? Because I think about this for a second. I don't know what it is. So I'm like, yo, ChatGPT, what do I do? Fuck. I don't think that's too good, man. And then it just simplifies that. How? So V. Oh, shoot. Wait, V transpose. That means this should be the rows turn into columns. So, and then, so it should be like that. So that means we get normal V, which is this guy. The negative is here. Then e to the negative 3 is 925 to the negative 3 to the negative 3. Is that the same thing as that? What is a negative power at? A negative power is what the heck is a negative power? I mean, it could be written as, is it just the inverse times 3 times? Just the inverse 3 times? Is e to the negative 3 the inverse of 3, the inverse of e to the negative to 3 to the third. What the fuck? That's not what I meant. It's not what I meant, bro. It's not what I meant. Wait. Let me in. It is, right? Yes. Frick, so I have to find the inverse of e is equal to... So quickly find the inverse of this guy. Inverse. We could do the simple thingy, but I don't really feel like doing that. We're gonna do this. Great. Didn't know that was a thing. I'll just do it. Matrix multiplication. Nope. One 9 0 0 125 1 1 9 0 0 125, and then I guess from the right 9 0 0 125 1 9 125 1729 15629. Then UT is simply just transpose of this guy here. All right. Awesome sauce. So 0.236, 707, 0.667, 0.236, 0.707, 0.667, 0.1, What the hell? Oh, just 0. All right, so we're good with the homework now. Let's go ahead and turn it in. Awesome. Good work, ladies and gentlemen. Homework 7. Okay. Homework 7, May 574. So let's go ahead and throw this over here. Boop. Right, good work, boys. Okay, a little bit late. Sorry, guys. So we will go ahead and switch gears really quick. Um, got a lot of stuff to do. What the heck is this? What? All right, so the first thing we're going to do is review a little bit of linear regression. Let's go ahead and do that. We'll review the whole slides, do a little something real quick. And yeah. Should we review the code? Maybe? Maybe. Maybe. We'll see. I mean, why not? Really. So let's just go through it. Just throw some notes in here. Right. Yeah. All right, let's go. Let's go. AAI 596. All right. So, let's do linear. Oops. Linear linear regress. So regression versus classification. Regression predicts a value. Classification predicts a class. Why are there more bullet points? Okay. Quick refresher. So training set is a pair of X vectors and Y targets, such that X is in X. Yep, and wait, what? Sure. The hypothesis or prediction function is all the data gives an output of Y. X is an image, Y contains cat or not cat. X is a house, Y is the price. Yeah. So given a training set, our goal is to produce a good prediction. Training set, learning algorithm. Yep. How to define good? It's the model in question. We want to use H on new data, but not in the training set. All right, supervised learning, linear regression. All right, housing data. Let's see, sample, line fit. Great. So something strange that I thought was hard to think about was we have a theta that is just the y-intercept. And then we also have a theta for the size, a theta for the lot, and a theta for the bathrooms. But whatever. And a convention that x0 is 1. Sure. So we have this. Here's a little example prediction. So should we try and recreate this right now with memory? Fuck it. Why not? Why not? It'll get us just that more familiar with the simple process. So let's just go to Google Colab. Open Colab. Let's get a new notebook going. New notebook. AAI, linear regression. You know what? It take a shit ton of time, but we can really get a solid grasp of linear regression and even turn it into a YouTube video. Ooh, that'd be pretty cool. We might do that. All right. Anyway, I gotta pee real quick. I'll be right back. Looks like someone texted me. I only have text from the family here. Let's go piss. So I was thinking on the elevator ride. We're not gonna do a whole video, edit it and shit. We're just gonna grab all our knowledge in the next couple hours, aim for about 2.5, and then lecture for like 30 minutes on what is linear regression. And then, so in that case, right after that, we can start the homework of implementing it from scratch. Okay, so let's go do it. Linear regression. All right, so let's try and do this from memory. Shoot. Import numpy as np. Import matplotlib. Pyplot as plt. Import pandas as p. So how do you generate random data? It's a good question. Fuck. Shit. Yo, I forget, bro. Rand int. So that would take 5,000 and 20,000, and we'll do size equals. Oh, look, it says right here. Why? Parameters size is int or tuple ints option. Great. So size equals 50. So we'll do so that would probably be, I don't know why it's X, should be Y. Oh, we have synthetic data for, okay, so we'll have lot area, bedrooms, and bathrooms, and price. So we'll say we got all these random areas, lot areas. We'll have bedrooms. Bedrooms equals mp.random.randint. Bedrooms would be like 1 to 5. Is it exclusive? Inclusive to exclusive. So we're going to say 6. Then we'll have a size equals 50. Then we'll do bathrooms. Bathrooms equals mp.random.randint 1, 2, 3 with a size of 50. Right. So then our y is going to be equal to lot areas and any noise. I'm not sure how this works. The noise.np.random.normal. Oh, wait. I know how it works. We have noise is np.random.normal. And it's just going to take a size. Oh, no. 0 to, say, 10,000. And size equals 50. So this is just random stuff that we're going to add to the equation. Lot areas times I guess it could be $1 per, or price per square foot. Okay, never mind. Times, so we say price per square foot equals 5. We'll say base equals 50,000. We'll say bedrooms equals, I don't know, 10,000. 1, 2, 3. Bathrooms equals 5,000. That's what they put. So we'll get y equals lot areas plus times price per square foot plus base plus bedroom and bathrooms plus bedrooms times bedroom plus bathrooms times bathroom plus noise. So that's how the noise works. I don't know why would it be rand int. It's sus, right? Why not rand int? I mean, we can make it rand int. I don't know. I don't see the reason why to do that. You can ask ChatGPT. I'm assuming it's from the normal distribution, NP random not normal. Just a random number from the normal distribution. But we don't really. What is that a mean and standard deviation? Well, location scale. Parameters is the center and scale is the, oh, okay. So I mean, like, bro, it doesn't matter. We can do a random integer, 0 to 5,000, size equals 50. I feel like it's the same idea, really, just some noise. X is going to, so, X. So we have a Y. We want to predict an X. What does linear regression take in? What's it called? What the hell is it called? Documentation. And how do you even import sklearn? Import sklearn? No, we have to import the linear regression. Okay. So we take in some data. Take in some data, and we also take in the Y value. Fit linear model. So we have the sale price. We want the the X. We want to predict the X. So wouldn't we give it this matrix here? Lot area. I see. Because data framework. Data frame. Okay, it's a dictionary. So let's say lot area. Lot areas. You'd say bedrooms. Bedrooms. You'd say bathrooms. You'd say noise. No noise. Oh, and you give it also sale price. Oops. Sale price. And you give it Y. So that's the actual. So this is the actual. And so, wait a sec. Wait, I'm confused. Based on this data, we have an actual thingy, an actual target, real targets for these datas. And what linear regression is doing is that we're having we're making an equation. So if we give it more data, it's going to spit out a predicted Y. Okay. So then why does the data frame include this? Pre-trained linear regression model. Okay. Then model equals linear regression. So then you'll do model.fit with the X, with the data from plot area, bedrooms, and bathrooms. And so I think this is a data frame. I'll say data equals PD data frame. So that is a data frame itself, and it has to equal a parameter. So data, not a data frame. I think this gives you a array. So if we do predictions equals model.predict, so we say sale price equals predicted predict. equals models dot model dot predict data. Predictions equals model dot predict data. So what does that return? Returns predicted values. What the fuck? I guess you can use that for the goodness. So now that we fit it, what does that mean? Fit returns a fitted estimator. What the fuck? What the hell? Returns a fitted estimator. So model dot. So then how do you use this on a new thingy? Oh my God. I'm not good at this machine learning shit. So model.fit this. And so, oops. So this takes in a fitted estimator. What the heck is that? What the heck is a class? Model.fit this shit. So then what do you do after that? Wait, what the heck? How did you not error? Okay, so now let's plot this. You can do ply dot plot plt dot plot how do we plot these? How do you plot this? We have predictions, which would be the y. What would the x be? Y is the mount. X is the what? I'm so dumb. How do I visualize this? If we have, how the heck do I visualize this? Linear regression. Well, why can I? A lot. But Can I not visualize this because it's more than 3D? It's more than 2D. Sure. Yeah, right? You can't really... Huh. Can't really return the... You can't really predict... You can't really graph this too well. Okay. Whatever. So that was just a little bit of practice, just doing a little bit of whatever. Let's actually get back into this. All right. So, great. That's our prediction here. Cool. So, we have a cost function, and we know that a cost function measures the error. Wait. Maybe. So, assume our prediction is that, and we want to choose the variables such that we predict really well. So a cost function measures the distance between our predicted value and the actual value. So basically the error. And one popular one is the least squares regression one. I remember the equation is, well, I saw a little bit of it. It was 1 n minus 1 over the times the sum of, is it literally just the sum of the the predicted minus the actual squared? I guess so. Oh, it's not n minus 1 though. It's 2m. So the amount of data, right? Yeah. So that's going to be our thingy here. And argmin probably means the what is it called? The converge, the converge stuff. So, how to choose this guy? Alrighty. So, iterative idea starts with a random guess. Okay, so there's two approaches: gradient descent and normal equations. So gradient descent is an iterative approach. We start with some random parameters for our line, and we would simply just make a change to these parameters and to make the cost function smaller and smaller until we converge. Okay. And normal equations performs the minimization explicitly by taking its derivatives with respect to the thetas and setting them to 0. So normal equations. All right, let's take a peek. Oh my lord. Oh my lord. My lord. Matrix derivatives. What the heck? Bro. What the hell is a matrix derivative? Yo, I'm so cooked for taking this class. But whatever. We're just learning more. Harder is better. So, our goal is to minimize the cost function by taking its derivatives to respect to this guy and setting them to 0. The goal is to find the best possible values for the coefficients. All right. Sure. So say we aspire y to be equal to our data times the vector. That way it is a m by n and a n by 1. Yeah, so n variables and variable amounts. Then that will give you a m by 1, which is the y. Okay, cool. 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 Wait, what's going on here? I guess these are just vectors. Sure. And then we get that. Right? Yeah. 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 Okay. Understanding normal equations. So, to minimize this guy by taking its derivatives with respect to this guy and setting them to 0. Minimize j theta by taking its derivatives with respect to the thing right here and setting them to 0. Minimize by taking its derivatives with respect to the and setting them to 0. That I feel like that's just gradient descent, but let's keep going. Say we aspire this, okay? Yeah. Hence, using the fact that for a vector z, using the fact that for a vector z, we have that ztz equals hence using the fact that for vector z, we have that ztz equals what the hell are you talking about? What?
Really? How the hell is that? How the hell is that a thing? Z transpose, I don't know, 1, 2, 3, 1, 2, 3 equals, you have Z, 1, 2, 3. Yeah, this is something I skipped over. Hold on. It's, okay. That is going to be a 1 times 3 and a 3 times 1, so just a value of that. So it's just going to be that. So it's taking the idea of dot products, right? Because if you have a long guy and a tall guy, the dot product, or I guess the matrix multiplication, is going to be basically the dot product. This times that equals boom. This times that equals boom. This times that equals, and they all add, right? So it's kind of like a dot product. And so I guess you can also say it's the sum of the squares. Okay, sure. So that means that we can have the least square cost function in matrix form as predicted minus Okay, so Z is literally just, this is what it was before, where Z is this, but I guess you can technically just do that and have the same thing. Okay, sure, but sure. But what is this again? Is this a vector or matrix? X times that. Oh, that's the predicted. That's predicted. So okay, so it's a predicted minus actual. So this is a vector. Anyway, yeah, it's big facts. That's what we just figured out. It's like this is that and this is that. To minimize this function, we take the derivative and set it to 0. Yo, my calculus, bro, is so cooked. I really got to review that crap before we head into the second half of spring semester, because there's a lot of calculus. It's in stats. It's in this class. Is that me? Chat. Was that you, chat? No, that was me. Okay, sure. Sure, that's the matrix form, whatever. Why does this minimize it? I don't know. I'm not gonna lie, I do not really know. I really do not know. A derivative is, okay, what even is a derivative? It's the slope of a point. At least in a normal 2D function. Or, I mean, yeah, 2D. But to minimize this function, we'll take the derivative and set it to 0. How, like, why? take the derivative and we set it to 0. Bro, I got no clue. I got no clue, man. Understanding the normal equations. To minimize this jaunt, we can find its derivatives with respect to and set that equal to 0. So what does that mean? Partial derivative. Man, should we really go into the deep hole of understanding normal equations, or should we just move past it? I'm honestly, I'm leaning toward just moving past it. But this is a fundamental right here, man. Maybe we can add it to the stickies. To do, bro, let's just throw all this out of here. Some deep dives. Normal equation in linear regression and why works. All right. So yeah, that's the idea here. It's this equation, and yeah. How the where did this come from, bro? That's so crazy. Minimize by taking its derivatives and setting it to 0. To do so, we first introduce some notation. All right. So, head out over here. Take a peek at our homework 2. So, all right, we open it and we do our normal equation here with this simple stuff right here. Just plug in the equation, really. And let's go ahead and open up the homework. Nope, homework 2. Homework 2. All right. Hands-on linear regression. So the normal methods with the data set. You can generate your sequence having the same length as the data number and shuffle it at random. Setting the other as the testing set. So now we'll do stochastic gradient descent. MSE versus iteration for both the training set and the testing set in one figure. All right. So let's take a peek at gradient descent now. Let's work through a little example to understand what's going on. Looks like we have a lot of code here, actually. So let's check it out. All right. So batch gradient descent, we know that that is going to be a whole data set, throw it into the algorithm, and we get back the thetas. Proceeds the entire data set. All right, for one iteration to update a single update of the parameters for one iteration. Straightforward, yields a smooth convergence path because the entire data set determines each step. And let's look at the gradient algorithm. So we have a loss function or cost function right here. And we find the gradient, which is going to be like this. It is simply, let's think about it. Why is this the gradient? Gradient with respect to parameter theta j. Find the gradient with respect to. All right, we're gonna pull up back here in a moment. I'm gonna go pee again and just snap for a little moment. So honestly, this subject, linear algebra, is giving me a bit of a headache. So we're gonna just switch keys a little bit, and let's work on. Do on 26th. So let's just make a quick turn towards something. So go ahead and hit lab 6. Figure out what's going on over there. First, we'll review the code one more time. Let's go ahead and take a peek at the lecture. So let's see these comments first class again. Discord. Wow. No way. That is sick.
April 2nd, 8 a.m. to 5 p.m.
This is my school. Anyway, let's get back to work. At lab 6. Okay. So, yeah, told this later. Take a peek at the project results. So, we're gonna have to do lecture 60 here at development and intermediate. Alright, let's take a peek at the lecture slides. Lecture video, advanced intermediate. Alright, so let's go ahead and get out the interesting code. We also got lecture 6. Take a peek at the intermediate Mongo, or the advanced Mongo and the intermediate API. So advanced Mongo. Import advanced movies from mongocollections.js. Advanced movies from mongocollections.js. So, right, find by director. So that's how it holds on. We have our collection, our connection, simple boiler code. And we have advanced Mongo and advanced startup docs. You must provide an ID. More simple stuff. Get movie, get all movie, and advanced finding. Get all movies, director cast only. So movie list equals await movie collection. I'm not sure what find is. Okay. And we project with ID 0, title 1, info director 1, cast 1, and into array as well. So no ID, we want the title, we want the director, and we want the cast. All right, get all movies sorted by title. All right. So we can take a peek at the lecture slide MP4. Why not? And I don't have to download it this time. Actually, storm rays and MongoDB entries and primitives and models. Bro, these it's not going to be in Mongo. For example, these are dollar signs, right? In potential ratings. Yep. Not in potential ratings. Less than starting year. Cool. Find. Okay, I see. Based on a Boolean. And this is, and we know skip is skip the first two. Limit is limit the amount you return. You can also sort by something. Let's see, the project is, what you want back. That's pretty cool. Like what specific fields you want. Okay, cool. Well, it's greater than 2. So you're saying quantity greater than 20, inventory, the carrier fee is greater than 2, and set the hook. Let's look at it greater than, check it out as well. Greater than, is that it? Bro. Mhm. That's pretty. Do we have any updates here? Update 1. Update 1. You update the given ID. So the thing with the ID, so it takes the ID and it gets it, and you would multiply the rating by 2. Huh, cool. Double rating. Update. Yeah, interesting. Very tedious. I could smell that this lab is going to be extremely tedious, but it's definitely going to help build the syntax knowledge. Yeah. All right, now let's talk about the API stuff. Okay. Let's go to was it Postman? Postman. Yes, I would love to sign up. We can just watch the whole thing, really. You can access the data that was sent. DB and post and Okay. All right. So pretty chill stuff. Let's sign up for Postman. And just get to it. Username, Nelson Romeo. Password. Let me choose my own. I cannot see if there's cap locks. Nelson. Very strong password here. No. Create a free account. Then how do I download this thing, baby? So API development is very strange, this idea of API. I don't know why, but for some reason, maybe I haven't looked hard enough, but in all my experience, which is slim, I don't know what is an API. Is it a thing, a code that can put post, whatever, patch and delete? Is that what it is? Is that an API? I think so, actually. All right, so that is loading up. Oh, it's a website? I thought it was a download. So if we go to modules again. All right, so that was a nice video just to refresh what we're going through right now. So we'll take a peek at the code walkthrough. We'll take a good peek at it, but I don't think we really need to get too heavy with it. Of course, it's so shitty. Is it also shitty on? Alright, so I guess we'll just download this humongous thing into my computer. So that's onboarding. That's my name, Nelson. Yeah. What is your role? I am a student. All right. Gigabytes. Should I have enough? May as well throw out some trash while we're at it. Oh, there's really no trash here. Yep, it's good enough. So we'll let this all load. I gotta go pee. I'm gonna go eat a quick dinner. I'll be right back in like maybe 10 minutes. Yeah, be right back. Maybe with my food. Who knows?
right. So, nice. It was a banger meal. Very, very, very banger meal. We're gonna switch gears for one moment and come back to this. We're gonna do some. Let's see what we have to do here. It may still be open. Hope so. Probably will not be because I closed it. But if we go to CPE, boom, boom, then if we check out modules, then assignments, then okay, ignore that. We're gonna cook it again. All right. Final project, team contract. Okay, she just gave back the points. All right, quiz for this week is closed for week 5. So we can do these two. Quiz for week 6. Yeah, so we did not save it open, unfortunately. So let's go ahead and give it, do our, do March 15th. Oh my gosh, bro. Damn it. Okay, so let's definitely start that as well. All right, so in week 5 is closed. Oh, shit. What even was week 5 for? So I'll have to ask him to reopen that. Quiz for week 6, though. So I think it'd be nice if we complete this right now. That'd be really cool. Past due 7 days. Okay, I'm sorry. Jeez. Failed to fetch. No. Available till March 17th. Oh, shoot. Let's do tonight. All right, so let's get all the questions in. I might close on me in like 15 minutes, but no biggie. We can close these all up. And we can close these. So week 6, let's see what it was about. Looks like probably these 3. Come on, man. What's going on? Okay. So might be able to open to be open for a while. Let's hope so. Oh, this is week 7. That was by accident, though. Quiz for week 6. That's what I want to open right now. Wait, what? Quiz for week 6 is quiz for week 7. So then
quiz for week 7 is out of 25 points. And quiz for week 7 is quiz for weeks. What? Wait, what? Oh, okay. All right. Cool. Oh, it's because you switched them up. So this one is Bayesian. Okay, so that means quiz 5 was the other stuff. So let's go over the Bayesian notes. We'll take a quick video just in case this closes on us. Okay. So let's take a peek at the Bayesian learning. Lecture 6. And I already have it downloaded here. So let's go through it. Bayesian learning. I want to get these quizzes out of the way as well as the homeworks. So it involves updating probabilities or beliefs about models or hypotheses as new data becomes available. All right. So let's do the probability of sickness, or we could do this example here on total probability. So a doctor knows that patients can have 3 different conditions: C1, mild flu; C2, severe flu; and C3, no flu. Hold up, chat. You guys are still here? Nice. All right. So the probabilities of these conditions are 0.3 of a mild flu, 0.2 for a severe flu, and 0.5 for no flu. Say the doctor wants the probability of a patient having a fever. So the total probability theorem is probability of B equals the probability of A1 given B times probability of A1 of AI. Fuck, other way around. B given AI. AI. So the doctor wants the probability of a patient having a fever, so PA. So that means we would simply have P having a fever, given that they are C1, right? Times probability of C1, which is 0.3. times 0.8 plus this times that plus this times that. Great. Awesome. Yeah. Then we have Bayes' theorem here, where this is the this is okay. I forget this is the prior, I think, knowledge. This is something, and this is the usually includes total probability, which is the data, maybe. So this is the likelihood, this is the prior probability, and this is the evidence. Okay. So let's take a peek at an example here. So we can predict either rain or no rain. This area has a 30% chance of rain. So the prior probability for rain is 30, for no rain is 70. Say we see dark clouds, I guess this is our data, so we believe it might rain. If the data, we have data, like if it's cloudy, there's an 80% chance that it will rain. So likelihood. So find the probability of rain given clouds. Using Bayes' theorem, that is the probability of clouds given rain times the probability of rain divided by the probability of clouds. Right? It's A, B, A, and B. Where's Bayes' theorem? Not the five. A, B, A, and B. A, B, A, B. Oh, that's a neat way to remember what it is. A, B, A, B. Wait, no, it's not. A, B, B, A. So, yeah. All right. Probability of, if it's cloudy, so the probability of clouds given rain is 80%. Like, if it's cloudy, there's an 8% chance of rain. What? Given cloudy. You know, that doesn't make sense to me. We have data like, if it's cloudy, then there's an 80% chance of rain. Okay, sure. 0.20. I wonder when this midterm is. Is it literally on one day, actually? Because that would be kind of crazy. Kind of funny, too. So let's see. We got modules. Let's take a peek at the modules. Let's go to the syllabus. All right. So our midterm is actually the next week. So that's a little bit good. So we'll definitely start studying for that now. There are no modules on the midterm, though, just yet. Yeah, there's nothing. So 4 minutes, this might close, but hopefully not. So probability of clouds, sure. So probability of clouds given rain is 0.80 times the rain, which we know is 30, divided by the probability of clouds. We don't know the probability of clouds. So we have to use the total probability theorem. Probability of clouds equals the probability of
clouds and rain times the probability of rain plus probability of clouds and no rain times probability of no rain. Right? Oh, it doesn't say. Let's assume that's the case, though. And let's also do this one, too. So it's a whole bunch of just figuring out, some probability theory, just getting it in your head, just understanding what's going on around it. Pretty chill. So a patient takes a lab test for cancer and the results are positive. Based on the following facts observed in the past, which is the chance that the patient does have cancer? Oh, shoot. I.e., all right, so patient, okay. It's probability of cancer given a plus. For those who have cancer, only 98% of the cases has positive test results. For those who do not have cancer, probability of no cancer and of a negative result and not having cancer is 97%. Cancer patients account for 0.8% of the population. So P, cancer equals that. So the probability of cancer given plus equals the probability of plus given cancer times the probability of cancer divided by the probability of plus. The probability of plus is equal to the probability of plus given cancer times probability of cancer plus the probability of plus given not cancer times the probability of cancer, not cancer. So it says that right here. Yeah. Cool. So let's move on to maybe the code even. There is not much code here. He's a little bit sussy baka. Okay, whatever. Choosing the hypothesis. Given the training data, we want the most probable hypothesis. Maximum, a posterior hypothesis. We want the max of this. And divided by P. So, all right. Did the quiz close? Ah, fuck. Fucking did. Given the training data, we want the most probable hypothesis. Given the training data, we have most probable hypothesis. Given the training data, we have the most probable hypothesis. The maximum, a posteriori hypothesis, the HMAP. Freaky. HMAP equals arg max, so H map equals the arg max H in PhD, which is the arg max H in the hypothesis bubble of PDH and pH. And we exclude the denominator because if we max, doesn't matter. If we assume HI equals HJ, then we can further simplify and choose the maximum likelihood ML hypothesis. What the heck? Sure, bro, sure. Brute force map hypothesis learning. We aim to find the maximum A posterior map hypothesis by searching through all the possible hypotheses in a given hypothesis space. What the hell? The term brute force signifies that the algorithm does not use any shortcut or optimization. Yeah. It simply evaluates everyone. For example, when working with a simple binary classification, the hypothesis space is, I guess, why is there 3? Why is there 3? What the hell? For example, why is that the case? Why does the hypothesis space H equal H1, H2, H3 for a binary classification task? Isn't there yes or no, and that's it? Why is there 3? Fuck. All right, whatever.
can stop. I guess does not matter. Given a binary classification task, the hypothesis space is H1, H2, H3. For each hypothesis, we compute P D given H and PH and select the highest. Yes. H map equals. This is very different than what we've seen so far, this probability stuff. I'm a bit confused on how it relates to predicting things. I have to pee. I'll be right back.
map and LCE error. So many LCE based learners output map. You just said they're two different things. What do you mean? Well, I guess they are the same thing. It's just a little simplified. Real value function learner. Consider any real value target function f. Yeah. Sure. I mean, okay. Consider any real value target function f. Training examples xi and di, where di is noisy. Training value. Neuron independent. I have no idea what this just said. Consider noisy training value. Okay. No, fuck that shit. Uh, okay. Okay. Sure. I really hope one day, hopefully this summer, for most of the algorithms, most of the data structures, most of the models, I can really take this complicated stuff and explain it in such a nice, simple way. All the calculus, all the linear algebra, and all the statistics as well. Really get the foundationals out of the way while doing some research papers too. That would be epic. Maximize the natural log of this instead. Okay, so I'm not really going to write too much of this down, but we'll end up maxing some crazy shit like this. Simply as this. Most probable classifier for a new instance. Given a new instance X, what is the most probable classification? HMAP is not the most probable classification. Not the most probable classification. Consider 3 possible hypotheses. What is the most probable classification? Is not the most probable classification. P H1D. Wait, what? I guess negative. Okay. So we'll just keep trucking through this. Bayes optimal classifier. Okay, argmax of Bayes optimal. This is why you kids shouldn't jump straight into machine learning given the first chance, right? Because math is intensive as heck. On my own, I'm so lonely. I'm so lonely. I have nobody to call my own. Example. No other learner outperforms this method on average, given the same age and prior knowledge. Drawback, computationally costly. So, no other learner outperforms this method on average, given the same age and prior knowledge.
The drawback is the computational cost. Example. pH1D equals 0.4. What? And this one's goofy. This one's a little bit goofy too. All right, let's go Canvas. $546, $595. Let's go to lecture 6. Let's go throw that into save the files. For show. Files. Lecture 6. Key takes. Why is Bayes' optimal classifier ideal? Theoretically optimal because it considers all possible hypotheses. Because considers all possible hypotheses. Robust because it considers the uncertainties. Robust because considers uncertainties and minimizes expected risk by using all the cost of classification errors. Minimizes risk because uses cost of classification errors. Yep. All right, next. Gibbs algorithm. All right, so we will get back to this. For now, I know it's not the most awesome thing in the world. It is not the coolest thing in the world, but we're going to go ahead and look at some Kaggle code, really understand what's going on in them. Think about the methods implemented, try and pick up on some patterns, and put them on our resume. Recode them and put them on our resume. We just need a little bit of filler for our application. I'm hoping to get 3 simple projects done throughout the course of the week. so we can just put them on our application, just so we get a little better chance of this airs thingy, majiggy. All right, so let's look at some code. Check out. DNet Analytics, banking, competition books. Ooh. Ooh. Let's look at a filter. Maybe biology. Let's look at the top votes. 8 years ago, 4 years ago, 5 years ago, 2 years ago. Whoa. Bioinformatics basics. Sequence definition, reading sequence fires, and cycloogenic analysis. Let's see what else we got here. Candidate generation and Luna 16 pre-processing. What the heck is that? Single cell classification, distributions, big data, drugs. Maybe this one. Protein. Exploration and baseline. What is this? Battery train, COVID-19 data. Yeah, I always wanted to know what the heck XK boost is. I'm gonna take a peek at this. All right. So let's go ahead and check out what's going on in here. BioPython, Bioinformatic Basics. The BioPython project is an international association of developers of freely available Python tools in computational molecular biology. There's modules and classes. Blast, FASTA, GenBank. Oh wow. And even documentation. Cool. Andre, check out what they got going on. Tackle bioinformatics. Whoa, that's pretty cool.
Take a peek, see what's going on over here. Interesting. All right, whatever. Let's take a peek at this. All right, let's go. Beginner entry operations. So by is a very convenient tool. All right. Well, it's going to be interesting to work with your own classes. It's much easier and less of a hassle to work in BioPython. So let's go ahead and run a little Google Colab here. Google Colab. Just take a peek at what's going on. Hit this, hit that. Yep. Boom, boom, boom. Open Colab. New notebook. All right. Biology 1. Bioinformatics. Python. Start coding. Python is a great tool you can use when working sequences of protein-based substances. Two sets of alphabets are used in bioinformatics: the nucleotides and amino acids. So among molecules with a biological role, we can find nucleic acids. Genetic code is kept within a cell. So that's code. The nucleic acids. Nucleic acids encode and express the genetic code that is kept within a cell. Are two types. Deoxyribonucleic acid, DNA, and ribonucleic acid, RNA. DNA contains information contains information necessary to build a cell, keep it functioning. In the cytoplasm, eukaryotic cells, DNA, found in the nucleus, while in prokaryotic cells, it would be found in the cytoplasm.
Pretty sure eukaryotic cells are for like normal animals and stuff. And prokaryotic is like diseases and shit. Yeah. Amino acids. Amino acids. Amino acids are the building blocks of proteins, which are macromolecules that perform most of the functions inside the cell. Proteins have a broad range of functions. Enzymes are a type of abundant which promote chemical reactions and convert certain molecules into other types of molecules required for the functioning of the cell. Okay. Carbohydrates serve as an energy storage. Lipids doing signaling signal and energy storages. DNA strands. All right, so DNA. DNA is a molecule composed of two complementary strands that stick together due to the chemical phenomenon where due to the connections established between the nucleotides in both strands. This is made possible due to the chemical connection. this phenomenon is due to adenine A bonds with T nucleotides. So what is a nucleotide? What is it? Not sure. Because of hydrogen connections. This is quite interesting. Honestly, it's pretty sick, not gonna lie. Might take me the whole week though. So we might just get one project on our shit. But might be able to get two if we really hit the books. You know what I mean. But we gotta prioritize our own homework, so we might just get one done. We'll see what happens though. Some nice, cool music. Let's put a clock. Let's put a timer on for about 30 minutes here. And at 2:15, we'll head straight to bed. We don't have a freaking toothbrush, so that sucks. But whatever. I wonder if I know this guy is always on some stuff. Some lives. Nope. Look at this. What the heck do you mean from scratch? This guy is pretty cool. Anyway, I want some nice music for the background. Let's see. Nah. Understanding transposes. What is there to transpose? What is there to understand? Shit. Damn. 800-page proof. Holy schmoly. Sure, I can listen to what this guy yaps about. Yo, can I please just get some music? I know all these things are really freaking cool, but let me get some darn. Oh my gosh, man. Let me get some darn. Cool music. I don't know. Core. Like music. I'm looking for some weird core. Weird core, ambiance, music. Yeah. Let's check this one out. Pretty sure. I'm new to this, all right? I'm not too sure. Okay, it's hard. All right. Anyway, I was just calling my mom. So how do I use uh, the sequence class? It might be different, so let's see if it is. Bio dot news sequence.
Phone, why not? Sec. Sync. Go ahead and do this right here. Since we don't have not enough details, you'll have to know the sequence that we're using, so it makes sense to give the names accordingly. An example operation you could plot on the time sequence could be the reverse complement, which is an operation applied to DNA-based sequences. To a DNA-based sequence. Print seek and that reverse complement is not actually possible. By a reverse sequence. Reverse complement. Operation. I feel like there's not too much. I think it's a great introduction, but I don't think there's any actual project. Looks like that. Maybe so, maybe so. This is crazy. I feel like this is something to save for another moment. This is a good one. Chill. It's pretty nice to look at. So let's try this one out. Afterwards, or actually right now. So we'll try this one out. See if we can get it working. Or we can try this one. Very interesting. Holy fuck. This is crazy. This might be too big, bro. Man, it's amazing, bro. Try this one out. At least what this thing did was kind of introduce me to things So yeah, we'll come back to this at some point with my but we need to get started. Close this session. Oops. This guy. You're gone. All right. So that was interesting. We'll switch gears back to this. I gotta go take a shit first. I'll eat this apple too. gonna go to sleep now. I might as well get 8 hours of sleep if I'm just gonna be literally studying all day with like zero human interaction and zero breaks. So the more sleep the merrier. So I'll see you guys. It was a cool stream. Love you.